Remember, when you're multiplying, it's like you're finding the area of something, because area is length times width. So it's like you're trying to find the area of a room that's 34 feet by 56 feet. So what you're doing is you're sharing the 34 to the 50 and the 6. So if I wanted to make this problem easier, when we think back to our box area, I could think of this as 34 times 50 and 34 times 6. So the 34 has to get shared to the 50 and the 34 has to get shared to the 6. So when I set up my problem of 56 times 34, I need to remember that, because I know I need to share the 34 to the 6 and the 34 to the 50. So I'm going to start with the 4, which is in my ones place. 4 times 6 is 24. The 4 goes in my ones place, the 2 in my tens. Now I went up, then I need to go over. 4 times 5 is 20, and I'm going to think of it as a 20 because it's going to end up in the right place values, but I have 2 more 10s to add to that, so 21, 22, which would really be 220, but if you think about it, it ends up being 220 without me having to write the extra 0, because the 4 is where that 0 would be. Now I've already shared the 4 to the 6 and to the 50, so I can cross it out. And now I can move over to that 3, which is really a 30. So because I have a 30, I crossed up my ones place because I'm done with it. Anything times a power of 10 is going to have a 0 at the end. Then I'm going to go over again. So 3 times 6 is 18. So the 8 would come down into the tens place, and then the 1 would be brought up. Now I'm going to go back up, and if you'll notice, you've made a pretty bow tie, and do 3 times 5, which is 15, plus that one other I carried over from before, which is 16. Now I know if I really did 30 times 50, I would have 1,500, and really what I'm adding on is that 100 I carried over, and that's how I get that 1,600. But watch, when I put it in my place values, it automatically goes to the thousandths and to the hundredths. So now I can add those up. For my final answer of 1,904. It makes no difference when you're working with a 3-digit number for 146 times 28. The only difference is I have more steps. So you of course can ignore that 2 at first and just think of 146 8 times. So I'm first going to go up. 8 times 6 is 48. Bring up my 4. Then I'm going to go over. 8 times 4 is 32. 33, 34, 35, 36. Since I still have another place value, I need to carry it. So I'm going to put the 6 down and carry those 3 tens. So I have another over to go to. Then 8 times 1 is 8, 9, 10, 11. So once the 8 has a line drawn to each number, then I'm done with it. So I can cross out my 8, my 4, and my 3. Now I'm done with my ones place, so that means everything has to now start in my tens place. I'm going to go in the same order. So if the 8 went to the 6 first, the 2 also has to go to the 6 first. So now I'm going to follow the same order. I'm going to go to the 2 times 6, which is 12. Bring up my 1. 2 times 4, which is 8, plus 1 is 9. And then 2 times 1, which is 2. So again, whatever order I follow with that 8, I follow the same order with that 2. And now I can add it together. When you're working with division, we're trying to say how many groups of 4 can we fit into 265. So we've been talking about partial quotients, or some people call it the big 7. So my dividend, what I'm breaking up, goes inside, and my divisor, the groups I'm breaking it up into, goes into 265. So you're thinking about it like this. I have 265 cookies, and I want to put them onto 4 separate plates. So I need to see what equal amount can I put them onto 4 separate plates. So what I like to think about is this number right here. I think 4 times what could get me close to 26? So if I'm thinking of multiple towers, 4, 8, 12, 16, I can do it that way, but I can also look at a multiplication chart or use my basic facts and think, oh, I know 4 times 6 equals 24. So if that's the case, then I know 4 times 60, because it's 10 times bigger, is 240. So I'm going to say by saying 4 groups of 60, because I know 4 groups of 60 is 240. Then I'm going to subtract out that group. 5 minus 0 is 5, and 6 minus 4 is 2. So now I'm going to say, how many groups of 4 can go into 25? And look, I've already thought about that and figured that out. I know 4 groups of 6 is 24, and that's really close. So 4 groups of 6 is 24, so I'm going to take out a group of 24, and I just have 1 left. And I can't split that 4 into the 1. So I was able to take out 66 groups of 4 with a remainder of 1. That means I can make 4 groups of 66 with 1 left over. When I work with a 2-digit number, it's a little bit different because it's a little harder to use our basic facts since 18 is not a basic fact. You could guess and check, but another thing to do is make that multiple tower and think, well, 18 times 1 would be 18. If I think 18 times 2, I'm just doubling 18. 18 plus 18, which would be 36. If I want to add another 18 onto that, I would think 36 plus 18, and think 8 plus 6, which would give me 14, carry the 1. 3 plus 1 is 4, and then that'd be 54. And then I can keep going if I want, but for right now I'm going to stop. So if I'm thinking 18 times 1 is 18, and 18 times 2 is 36, well then I can say to myself, 18 times 20 is just 10 times bigger than that, so 18 times 20 must be 360. That's going to get me really close, so I'm going to take out 20 groups of 18. And that's going to take away 360. And now I'm going to subtract. 8 minus 0 is 8, 9 minus 6 is 3. So now I'm left with 38. But oh wait, I already found a fact for that, because I know 18 times 2 is 36. So I can reuse this fact and say I know 18 times 2 is 36, and then subtract, and that's all I can do. So my answer would be 22 remainder 2. So using those multiple towers and listing out your factors or your multiples for those ideas can be really helpful if you're stuck.